calculation. So for this, there are few steps. First thing is, you have to consider the circuit. In this circuit, there is one switch and a power supply. So this is a battery and a switch. This is connected to a P-type and N-type material. This is nothing but a diode. So a diode is now connected to power supply. But here, this until the switch is in an open condition, the battery is not connected to P and N. So there is no power supply given to the diode. Okay. First case, let us see. In switch, when switch is in open circuit, when switch is open circuit, what happens? There is no power supply given to the diode. So when there is no power supply, okay, what are the carrier concentration on ours? What happens generally in when you connect a power supply? When you connect a power supply, the charge carriers will acquire some kinetic energy and they will move fastly and they will break the barrier potential. This is what we have done. Barrier potential means what? It is a depletion potential which acts in between the P type of and N type of material. So this is the junction. Okay. When you are not given any power supply, what happens? There will be more concentration of holes in this majority and more electrons will be on this side. They will try to diffuse like this into this region and all the electrons will try to diffuse into this region like this. Are you able to follow this? Okay. So chala carriers, whatever the carriers are there on this side, will try to move. Now let us represent here the holes in P side is represented as P suffix P. Electrons in P side is represented with N. So this representation is very important to understand. And next time on N side, holes in N side and electrons in N side. Okay. So if we, what are the majority carriers? Holes will be the majority carriers in P side. Electrons will be the majority carriers in N type of material. They will try to diffuse from higher concentration to lower concentration. So I told you an example that when there is a tank like this, if one tank is very filled with the water and the other tank is completely empty, and if you join these two tanks like this, diffusion takes place, hence until it will become equilibrium condition. So this concept we know. The same situation will happen here. So now how to write the equation for this? It is given by the Boltzmann relation. So it is given as holes in P side is equal to holes in N side exponentially varying with the barrier potential by volt equivalent temperature. Okay. Now if your switch is in open condition, okay, let us see the first case. Case 1. When your switch is in open condition, what happens? This PP expression will change signs because your barrier potential is equal to V0 when it is in open circuit. So substitute this VB is equal to V0 in this expression. So holes in P side is equal to holes in N side exponential of V0 by VB. So this is the expression. But now we will try to close the switch and we will see the situation. When we go for case 2, the switch will be closed. When you close the switch, what happens? Two things happen. One thing is, more number of charge carriers will be diffused and there will be a drift current and diffusion current. So, there will be actual holes plus some of holes are being added. So, there will be an improvement of concentration or there will be more charge carriers will be collected. And another one is, there will be reduction of depletion region. What happens to the depletion region? It will be reduced. Initially, how much it is? It is at V1. How many times it has been reduced? Because we are giving a supply of voltage VB, it will be reduced by the V factor. So V0 minus V8. So VB is equal to, we have to substitute V0 minus VB. In the place of Pn, what we have to substitute? Pn plus delta V. That means when you give power supply, there will be a drift current and diffusion current. Therefore, more charge carriers will try to enter into another region. So, how many more charge carriers have been entered will be given by Pn actual concentration plus additional concentration gradient, that is delta Pn. Now, let us substitute and see this expression. So, here holes in P side is equal to holes in N side, okay, plus delta Pn into exponential of V naught minus V into divided by V. Now let us expand this expression here, that is Pn plus delta Pn into e power V naught by Vt minus into e power minus 3 by V. So 2 times I have just expanded this expression. On this side we have holes in P side. We know this expression, holes in P side can be written as holes in N side exponentially varying with respect to the barrier potential by the volt equivalent temperature. So we will write this expression Pp means Pn into e power. What is the expression when it is at when your barrier voltage is open condition? It is e power V naught by Vt. We will not write the standard expression. We will write the first initial condition. So it is e power V naught by Vt is equal to Pn plus delta Pn into e power V naught by Vt into e power minus V by. On either side we have e power V naught by Vt, and this side also you have e power V naught by Vt. Then your expression becomes Pn is equal to Pn plus delta Pn into e power V by Vt minus V by Vt. So this is the expression we got. And now shall we shift this exponential factor to that side, because we want to find out what is delta Pn. So in order to find out this, what is the change in the carrier concentration in the holes, we will try to move this expression, exponential factor to that side. So what is the expression? We will get Pn into e power V by Vt becomes V by Vt is equal to Pn plus delta Pn. Now to find out this delta Pn, okay, there is no need to write again these brackets. To find out this delta Pn, what we have to do? Again, this Pn should be shifted this way. Then we will get here Pn into exponential of V by Vt minus 1. Can I write like this? Minus 1 is equal to delta. Now, all the expression is in Pn, but what is this Pn? Can we able to write it in another form? So yes, we can write it here. Pp is equal to Pn into e power V naught by Vt is there. If I want this Pn, Pp into e power minus V naught by Vt. So again, I will write here Pp into e power minus V naught by Vt and into e power V by Vt minus 1 is equal to delta T. Okay? Now you got the expression Pp. Okay. Now here the current expression. So the total current is proportional to the whole current in N side is proportional to your delta P. Then automatically, as a consequence, again the current will be proportional to also Pp into e power minus V naught by Vt into e power V by Vt minus 1. If it is proportional to this one, then we can write a proportionality constant to make it an equal condition. So here IPN is equal to, okay, IPS. I will take it as a constant, this entire factor as an IPS, and I will write an expression E over V by Vt minus 1. If I get the expression for the current due to holes in N side, then I can also write current due to electrons in P side. Okay, current due to holes in N side. Okay, then I can also write current due to electrons also. Then I can write current here. This is I we as we know that the total current will be due to the sum of the whole current and electron current. So we will write the expression as I is equal to ITM plus INB. Okay. Then I will write this expression as IPS plus INS. Okay. This entire expression will be V by VT minus 1. Now if I equate these two terms to I naught, then I can write this as I naught into e power V by VT minus 1. So this is the final current expression where I naught is called as a reverse saturation current, and it is exponentially varying with voltage by volt equivalent temperature minus 1. Okay, so this completes the derivation.